Just like food and energy, water is a very important sector for which adaptation is obviously very critical. The number of people who are facing stresses in the water access, quantity, quality is growing and is expected to get worse. In the meantime, there are also solutions being developed for water filtration, sanitation, desalination, and so on. In the context of climate adaptation, we must include adaptation in the water sector, of course. So I'm going to do two things. One, I'm going to start with this IPCC Chapter 7 AR6 report, which looks not Chapter 7, it's Chapter 4 and 8, I suspect. The report from the third working group 3 on impacts, adaptation, and vulnerability includes water as well. We used already some information from food, and we will do here the water first, and then I will go back to a book on adaptation in the water sector, which is a bit old, 2009. That's the first edition. Hopefully they will update it and produce a second edition sometime soon. But the adaptation principles remain the same, so the age of the book shouldn't really matter. Okay, so let's start with this. I'm going to take a very few points from this long chapter on water from the IPCC AR6 report. They have incredible amount of details, so I'm just going to filter it down to a few of the main points. Very subjective choice, of course. Strategies for urban water adaptation. You can read these here before you start. Strategies for urban water adaptation. Green and blue strategies of urban water adaptation prioritize ecosystem restoration, such as wetland restoration. You can already imagine that just like for hydrogen, we have rainbow colors for water as well. Green water is what falls down, and blue water is surface water, and then you have gray water, which is used water that's being recycled. Gray water strategies are hard engineering approaches to urban water adaptation, including infrastructure such as pipes and canals with extensive areas of impervious surfaces. They have impact on the water hydrology, especially in terms of runoff for the same amount of rainfall and so on, that we will not get into, but we will see how impervious surfaces have to be considered in water adaptation as well, and we'll see some examples here in the schematics. Hybrid approaches combine green, blue, and gray adaptation strategies, such as the ecosystem functions are such that ecosystem functions are complemented by engineered infrastructure such as constructed wetlands, green roofs, and riparian buffers. Green and blue and hybrid approaches are variously classified in terms of a circular economy, water-sensitive urban design, nature-based solutions, integrated urban water management, and ecological infrastructure. This figure comes from this paper here. So the circular economy terminology comes basically from something like life cycle analysis that we use for products and emissions and carbon footprints, but circular economy basically means considering the water from source back to recycling to restore some of the sources back in some sense. Okay, there are many terminologies that are new, but AR6 uses them, and we are in this course I'm not going into the details of what circular economy means, but there are in fact courses offered on circular economy and its principles as well that you can look up. Okay, so let's start with green or blue strategies, which depend more on ecosystems, as we said. So here you have precipitation, which is green, and then you have lake, stream restoration, runoff, transpiration affecting the water cycling hydrological cycle, evaporation, parks and grasses, which are part of the ecosystem management, including wetlands, constructed or natural, and you have issues to worry about in terms of water table, infiltration, and groundwater recharge. Okay, these are the kind of components of the green and blue water strategies you would worry about in taking the rainfall and evapotranspiration patterns. So temperature is affecting evapotranspiration, precipitation is coming as extremes and will affect the runoff and in general erosion, etc. So you want to worry about, make the running water walk and walking water stop, as they say, using these strategies in a very broad sense. Gray water strategies include piped hardwired structures. So wastewater treatment, stormwater drain, extensive impervious surfaces are involved, and we have pipes, canals, increased runoff because of these extensive impervious surfaces, and you have piped stormwater being piped out, cities being designed for rain rates and then quickly running beyond the rain rates that the design is for, creating flooding. Urban flooding is a big issue as well. And then you have concrete storage basins to try to manage the water issue, also in terms of managing the runoff into the coastal waters and so on, to prevent nutrient loadings and other contaminations of water quality in the ecosystems along the coasts or rivers and so on and so forth. Okay, so you have water infiltration plant here, but you still have precipitation. Transpiration is not shown, but you know that that's part of the overall water cycle as well. That comes in here when you look at hybrid strategies. So you are now combining blue, green and gray waters together. So you have porous, so you have some solutions now. Porous pavements, groundwater recharge being enhanced by bioswales. So you're trying to deal with rain rates, increased rain rates, extreme rainfall, etc., with things like green roofs. So this can also go into rainwater harvesting. Water table maintained, infiltration with bioswales. So green roofs helping reducing runoff, bioswales. French drains, riparian buffers, constructed wetlands and so on. So these are very broad schematics, but still these are very critical and are actually used in the adaptation responses in urban contexts for managing water and response of the hydrologic cycle to global warming and how that's changing the water management requires in the urban setting. Okay. Another schematic here, decision tree documenting the classification of water-related adaptation responses across 48 subcategories into 16 intermediate and 8 larger categories. We use the 16 intermediate categories of adaptation responses for further analysis in this section. Obviously, I'm just taking, for example, this is from chapter 4, this one is from chapter 4, then I'll jump to chapter 8 somewhere here, and so on and so forth. So I'm taking things just subjectively, as I said, from the IPCC Working Group 3 report on impacts, adaptation and vulnerability related to water, just because I wanted to have water as a section in this adaptation course. But as I said, water adaptation can be a whole course by itself. Okay, so here we have water adaptation response categories in the middle, coming from this side going into this side. So you have adaptation responses affecting things like migration, indigenous knowledge and local knowledge based, so spontaneous migration, employment and remittances, managed retreat, planned relocation, off-farm livelihood diversification, IK and LK based adaptation. So migration and off-farm diversification, IK and LK based adaptation, all coming towards water adaptation responses relating to crops, agricultural water management, urban and wash and energy related, livestock, fishery and agroforestry related as well. We'll read these in a minute. Okay. Here in the second link you have flood risk reduction. So you have migration and IK and LK based adaptation responses. Flood risk reduction responses. So flood risk reduction measures include non-structural measures for flood management. We talked about a few of the things here in terms of bioswales, French drains, permeable pavers, rain gardens, and so on and so forth. Early warning systems for floods, which is very critical, in fact, to convert weather forecasts into probabilistic flood forecast for urban areas and non-urban areas as well. Flood resilient housing and wetland restoration. So combination of nature-based and human responses, technological responses. Here you have incentives, policies, institutions, collective action, and capacity building, dealing with collective action and policies and institutions. Collective action and cooperation, community-based adaptation, local institutions, water dispute resolution, institutional policy responses. In terms of training and capacity building, you have information training, capacity building, behavioral changes, and you have economic and financial incentives as well. So you have insurance, so including crop insurance, microfinance, social safety nets, subsidies and incentives, water markets and tariffs, payment for environmental services, and finally you have any other, including coping. Okay, so that includes consumption or loss reduction and selling assets or any other. So under the categories on this side, you have crop yields, agricultural, water management related, urban wash and energy related, as we already said, livestock, fishery and agroforestry related. So you have improved cultivars and agroeconomic practices, changes in cropping patterns and crop systems. And under agriculture, you have on-farm irrigation and water management. So early warning systems for crop selection, water management, irrigation applications, fertilizer applications, nutrient management, etc. are very critical. Water and soil moisture conservation, energy related adaptation, so hydropower and other renewable, etc. Wash related adaptations here include hand washing and hygiene, safe drinking water and sanitation, for example. And you have urban water management under this category. And for livestock, fishery and agroforestry, you have livestock and fishery related adaptation responses, agroforestry and forestry interventions. Okay, so the next figure is a bit complicated, so let me read the caption first. The panel on the left side shows observed benefits of adaptation. So we will have current and future here. So observed outcomes are reported across 5 dimensions of benefits, co-benefits and maladaptation outcomes. So every time you do adaptation, which is an intervention, you have to make sure that intervention is not a massive maladaptation. So adaptation has to be flexible, as we have said, in that sense, to avoid maladaptation or respond to maladaptations, unintended, let's say unintended maladaptations, but that's not always possible to make flexible adaptations when hard structures are involved. Benefits are measured across 5 dimensions. Strength of evidence is high, so there's a lot of details here. If greater than 80% of adaptation responses in that category have at least one beneficial outcome, medium if between 50 and 80%, and low if less than 50%. Confidence in evidence relates to the way the article links outcomes of adaptation with the adaptation response. So we have categories. 1, studies casually link adaptation outcomes. Studies casually link adaptation outcomes to the adaptation response by constructing credible counterfactuals. So you look at what happens if there was no adaptation and what happened because of adaptation, and you derive benefits. Category 2, studies correlate responses and outcomes without causal attribution. In category 3, studies describe adaptation outcomes without making any causal or correlation claims between adaptation outcomes and adaptation responses. High confidence means more than 67% of studies fall in category 1 and 2. Medium confidence is 50 to 67%. Low confidence is less than 50%. Panel on the right side shows the effectiveness of future adaptations. Sorry, here we'll go back. Future outcomes are assessed in terms of their effectiveness to reduce climate impacts at 1.5, 2, 3, and 4 degrees C warming global temperature increase relative to the 1850 to 1900 baseline. Effectiveness is defined as the fraction of adaptation that the option is able to reduce. Residual risk is the fraction of risk remaining after adaptation. Remember, residual risk is never zero, so we have to be always prepared for residual risks. So you have to, from the beginning, plan for acceptable and unacceptable risks and who is responsible for them. Private sector versus government and so on. If greater than 66% of assessed data points agree on the effectiveness class, a response temperature combination is shown as belonging to that class. Kind of details that I won't get into in terms of explaining. Where results diverge, the result is inconclusive, with studies showing high and low effectiveness across regions and studies. Confidence is based on a number of data points available for each response temperature combination, with high confidence 5 more data points, medium confidence 2 to 4 data points, low confidence 1 data point is low confidence, and so on. So unfortunately, these tend to have long captions, and now you have to remember what I said and try to understand these, but let's just run through these. So water-related adaptation responses, current beneficial outcomes, co-benefits with mitigation and maladaptive outcomes of the responses, and future effectiveness of adaptation and residual risk under different levels of global warming. So we had 1, 2, 3, 1.5, 2, 3, and 4 degree warming here. Okay, so let's look at the currents. Improved outcomes here, mitigation, co-benefits, and maladaptations, and the circles come with high, medium, and low strength of evidence based on the number of studies and data points, and confidence and evidence as fraction of studies. High, medium, and low with these blue to orange colors for various sectors. Okay, I won't map one-to-one, but you can see what's in the improved outcomes: economic or financial for vulnerable people, water-related, ecological or environmental, institutional, and socio-cultural, with mitigation coefficients and maladaptive outcomes here. So water-related adaptation responses include improved cultivars and agronomic practices, changes in cropping pattern and crop systems, on-farm irrigation and water management, water and soil moisture conservation, collective action policies and institutions, migration and off-farm diversification, economic or financial incentives, training and capacity building, agroforestry and forestry interventions, flood risk reduction measures, livestock and fishery related, indigenous knowledge and local knowledge based adaptations, urban water management, energy related adaptations, water sanitation and hygiene. This is what I have been stating maybe wrongly a few times. So wash related adaptations, water sanitation and hygiene, multiple agricultural options, or any other, including coping with what's happening. So basically this covers kind of water related adaptation responses. Many of them fall in nature-based climate solutions, ecosystem restorations, adaptation for conserving biodiversity, energy, food, water nexus, health also projects onto many of these things. And then you are also worrying about mitigation co-benefits and maladaptation outcomes. So some of the big circles here: migration and off-farm diversification can have medium strength of evidence and confidence in evidence studies, and similarly for indigenous knowledge and local knowledge based adaptations. What about the future? Assessment results under different levels of global warming for 1.5, 2, 3, and 4 in terms of effectiveness, so potential to reduce projected risk. So projecting these water related adaptation responses into future water resilient systems, at least in terms of effectiveness and what remains as residual risks. Residual risk remaining after adaptation for various warming levels. Again, you have strength of evidence and residual risk versus confidence as number of studies, and there are of course few things that are not applicable or not studies. Okay, so I won't go into the details. You can see there are a lot here that are not assessed, so you have to be careful about future estimates of effectiveness and residual risk. Mostly we talked about adaptation where present risks are sufficient to develop adaptation plans and responses and hopefully make the adaptation flexible so that you deal with future risks and you deal with maladaptations along the way. But many times that's not possible, that you're just coping. And we also talked about how just being in a crisis mode can severely handicap building resilience for the future. This is true for the water sector as well. Okay, so we just have to deal with these in terms of managing the unavoidable. Maybe I should stop this podcast here and come back and do another one, since this is already over 21 minutes long. Okay.